Now we are going to discuss here Coulomb's law. Coulomb's law in electrostatic. It gives us the force which is acting between two charges. Say we are assuming these two charges Q1 and Q2, which are separated at a distance of r. Okay, so there will be a force of attraction or repulsion. Now this force of attraction or repulsion will be depending on the nature of these charges. If both of the charges are positive, then there will be force of repulsion, and if one charge is positive and another one is negative, then there will be a force of attraction. Okay, so it states that the force between 2-point charges is directly proportional to the product of the magnitude of the charges of their charges, precisely their magnitude of charges. Okay, second is inversely proportional to the square of the distance between them. Okay, this is the statement. Now simply this force either is of attraction or repulsion. Attraction or repulsion will be depending on the nature of the charges. If both the charges are positive or both are negative, then there will be force of repulsion. And one charge is positive and another charge is negative, then there will be a force of attraction. So now numerically we can say here F is directly proportional to the product of their charges. We have taken these two charges whose magnitude is Q1 and Q2, and they are separated by a distance r. Okay, so F is directly proportional to 1 upon r square. Now we can combine these two. So F is directly proportional to Q1 Q2 upon r square. Now this is the proportionality, and we have to remove this proportionality, and this proportionality will be removed by a constant k, Q1 Q2 upon r square. Now what is k? K is a proportionality constant. K is a proportionality constant. Its value will be given by 1 upon 4 pi epsilon naught. Now what is epsilon naught? Epsilon naught is the permittivity of free space, and its value is 8.854 into 10 raised to the power minus 12 Newton meter square per Coulomb square. This is the value which we are aiming for this. And when we substitute this value over here, K is equals to 1 upon 4 pi into this value epsilon naught. I am writing it here, 8.854 into 10 raised to the power minus 12 Newton meter square. So it comes to be nearly K is equals to K is equals to 9 into 10 raised to the power 9. So we can replace this, either we can use here 1 upon 4 pi epsilon naught into Q1 Q2 upon r square. This is the force which is acting or exerted by these charges, In magnitude it will be 1 upon 4 pi epsilon naught into q1 q2 upon r square, or we can write it in other way. F is equals to 9 into 10 raised to the power 9 q1 q2 upon r square. So this is the force which is acting between these charges. Okay. Okay. Now we have got this Coulomb's law. Now by Coulomb's law we have got F is equals to 9 into 10 raised to the power 9 q1 q2 upon r square. Now we will be defining the 1 coulomb of charge. So if we are assuming q1 is equal to q2 is equal to say 1 coulomb, or say 1 coulomb, which is separated at a unit distance or at a 1 meter. So what we are getting here, F is equals to 9 into 10 raised to the power 9, 1 into 1 upon 1 square. So F is equals to 9 into 10 raised to the power 9. Okay. Now if we have got this value, it means if we are assuming it is equal to also Q, so 9 into 10 raised to the power 9, which is equal to this 9 into 10 raised to the power 9 q square upon 1, it is going to be q is equals to plus minus 1. Now see here, we have got this q1 q2 is equal to 1, and we have got here F is equals to 9 into 10 raised to the power 9 Newton force, which is exerted by these two charges of 1 coulomb each, of same since it is both are is positive. So what we are getting, it is the force of repulsion when these two charges exerting a force of 9 into 10 raised to the power 9. So 1 coulomb is that charge which exerts a force of 9 into 10 raised to the power 9 Newton. Similarly, when I substitute this value over here and I am assuming this charge, both charges of equal magnitude, say q square, say q into q, that is q square. So 9 into 10 raised to the power 9 into this value is already there by Coulomb's law. So what we are getting, q square is equal to 1. So q is equal to plus minus 1. So here we can say it may be a force of attraction as well as force of repulsion. Okay. So 1 coulomb of charge, we can define it in this manner. Q1 is equals to Q2, 1 coulomb, which is separated at a unit distance 1 or 1 meter, exerts a force of 9 into 10 raised to the power 9 Newton. Then its magnitude of the charges will be 1 coulomb. Okay.